Welcome viewers to the Geo interview of Mr. Abhishek Singh. Uh, Mr. Abhishek Singh works at a major lithography solutions provider called ASML, which is an industry leader in manufacturing of photolithography machines and other semiconductor manufacturing equipment that have paved the way for continuing innovation and driving the Moore's law. So Mr. Abhishek is currently serving as an account manager in ASML to a major chip manufacturer. His insights in how the global semiconductor industry is operating and what the future holds comes from more than a decade-long experience in the industry. Currently, Mr. Abhishek is involved in supporting the ramp-up of the 12 billion TSMC fabrication facility in Arizona, United States, from where he is connecting with us. Um, Mr. Abhishek holds a bachelor's in electronics and communication from NIT Ahmedabad, an MSc in microelectronics and photonics from University of Arkansas, and an MBA from University of Elway. Welcome, sir. Hope you are doing fine.
Thank you for having me.
All right. So, to give our viewers a brief overview about what is photolithography, right? So, photolithography forms the basis of the modern semiconductor supply chain. The technology has practically commercialized the large-scale production of integrated circuits, as we know. The book Cheap War for the fight for the world's most critical technologies by Dr. Chris Miller. He is a history professor at Tufts University. He claims that lithography tools are the most complex and complicated mass-produced machine tools in the history of industrial economics. And we have a representative from an organization who is making that history in front of us, right? And ASML's UV photolithography tools have practically kept the Moore's law alive and going. So, being a market leader in the lithography and other cutting edge manufacturing tools, ASML is a certain level of vantage point in the global semiconductor industry that debatably no other player in the industry might have. Be it TSMC, Samsung, Intel, you name it, because ASML is dealing with all of them. So, keeping this theme in mind, the first question to you, sir, is ASML was once a lithography wing within Philips Corporation, right? And in 1984, it spun out of it as an independent entity. So back then, Japanese lithography makers such as Canon or Nikon, uh, who we see the photocopies and the DSLR cameras they are creating, they were also in the business of lithography back then. And ASML entered in the market at such a humongous competitive environment. So how did ASML sustain this initial competition?
Yeah, that's a very good question, and yeah, thanks for giving a quick introduction about the industry. And what you mentioned is indeed the semiconductor ecosystem has quite a lot of key components in there. In terms of if you just focus on the suppliers, so indeed ASML is one of the suppliers that is quite a bit in the focus and in the talks right now amongst all of the geopolitical things going on. And as you mentioned, if we talk about the technology itself, driving Moore's law, I mean, every step of the way. So the way that semiconductor chips are built, it's a very step-by-step process. However, lithography, if you look at those steps, lithography is one of the steps that is what, as you mentioned, defines the term that you hear node. Node essentially means the technology or how small your feature sizes are in terms of shrinking the electronics to the point where, if you remember how big the electronics used to be it TVs, be it phones, be it smartwatches and things like that. So things have been shrinking. But if you look at it, the computing power of these things has continued to increase. Your cell phone that you hold in your hand right now, or the way that I'm recording this interview with you, is more powerful than what our desktops used to be, or some of the desktops still are 5, 10, 15 years ago. So touching upon Moore's law, which is kind of, what it says is, as we continue to shrink every couple years, where we multiply or almost double the transistor density every couple years, but at the same time, what it is helping us to do is it's also helping us to reduce the cost and the affordability of this technology. So people like you and me not only talk about just supercomputers, which are very expensive machines, and it used to be, and a lot of time ago, they were used by the defense industry and the government industries in terms of being able to really do like very high level, high performance calculations. But now, if you look at your cell phones or your smartwatches, they're able to do much more than some of these older generation computers. So again, coming back to why ASML is so much in focus right now, amongst other suppliers too, is because lithography step is the one that defines what node the technology is in terms of the smallest feature sizes. So with that background, now coming back to what you said, so I want to touch upon a little bit of the history of ASML. So as you rightfully said, ASML started out in 1984 with a group of few engineers from Philips and also ASMI, which was Advanced Semiconductor Materials International. So they got together and basically created this new company, which was a few people, and they called it ASM Lithography, which is ASML. At that point in time, indeed, ASML was not, again, a well-known name so much in the market, and rightfully so. A lot of focus of semiconductor manufacturing was in Asia, particularly Japan, was the epicenter, which you mentioned, Nikon and Canon. Both of those are Japanese equipment suppliers, particularly for lithography. So ASML indeed had its in its initial years. So it started to grow, and then the first system that ASML created was called a stepper. The stepper technology is a PAS. It's called a PAS 2500 system, which was one of the first machines that was manufactured. It was a platform. So what a stepper means is, as the word says, step. So it would step at every point and expose a particular field on a wafer, which is like a round, almost like a pizza, like a 12-inch pizza, right? So it's a wafer. And it would expose each one of these dies, which are further dies down in order to form the chips. So that was our first machine that came out. And at that time, one thing, now coming back to your question, one thing that ASML has done, and I want to touch upon this history, because one thing that ASML has continued to do over the period of time is innovation. So continuing to drive the technology. But at the same time, in terms of the business piece of this, they have been making a lot of strategic partnerships. So Carl Zeiss in the 1980s was one of the first key suppliers of ASML, which is used to make these optical columns, which are used for exposing the light onto these wafers, right? So Carl Zeiss, which is one of the key suppliers, now also became a partner. So the two companies start to work together in order to essentially build the foundation of what will turn out to be ASML of the future. And again, now we're talking early 1980s. If you look at 1988, now ASML further started to expand into Asia, and after Philips essentially established a joint venture foundry in Taiwan, and then it also grew into US. At that point, they had 84 employees also there, and about 5 locations only at that point in the US. So again, it was not quite that big of a name that could go against, the likes of the Nikons and Canons of the world. What was also not working in their favor at that time, because they were the new kid on the block, they did not have enough customers, right? So what you want to do is, once you have the customers, that's when you can get those orders. But in order to do so, of course, you need to really prove yourself. You need to get those results, and that's when you establish your brand that you eventually, like ASML is now. So ASML continued to drive in terms of the technology, and they really believed into their roadmap. So this was one of the key things for them, that they wanted to make sure that they were always focused on making sure that they could have the best product out there in terms of having a technical advantage. At that point in time, one of the Philips board member named Hank Bott, he basically, when ASML was not doing so good financially because they needed money for R&D, he was one of the key people who actually persuaded his colleagues at Philips in order to help to find a financial support to keep things going. And that's when things started to get, a little bit more momentum. And 1990s was a critical period for ASML because that's when they actually went public. So ASML issued their IPO. And the biggest breakthrough they had at this point, they also introduced a new platform called the PASS 5500 Stepper, which was something that really brought a lot of customers on board. And this is when ASML actually started being profitable. So now ASML was a name that became profitable in the 90s. So if you look at it, just kind of recapping, in the early 1980s, mid 1980s to 1990s, ASML spent a lot of time focusing on technology, first struggling with the financials, but then establishing themselves with that financial into launching a good product. And now they had more customers and they went public so they could actually get more funding in order to keep things going. But at the same time, after it was listed in NASDAQ, as I said, with the IPO, and also listed in Amsterdam in the European stock markets, now ASML in the 2000s, this is when they started to separate themselves from the competition, from the likes of Nikon and Canon. And there were two key things technologically that they brought to the market that really differentiated them. So the first one so as a business, if you see, every business wants to make sure that they have a good product. But even if you have a good product, but you don't have a good market where it's affordable to the customer in order to get more value out of it, then you can't necessarily sell it because the price is too high, right? So the perception is, yeah, it's great, but I can't make money off of it. So what good is it for me? So ASML actually introduced their first technological, again, paradigm shift, technological change was a twin scan platform. Now, if you break down that word twin scan, there's two key things in there. Twin is two, right? There's two things. Scan is a different technology of how you expose it. So previously I said we used to use steppers, so you would step. Now you use a different technology that we introduced, we call the scan. So you scan and expose, and versus you step. The reason, and I will explain very high level, this is important, is by doing this kind of scanning technology, what it helped ASML to also do is you could introduce better control on how you would expose over the field, right? And if you have a topography on a wafer surface that is like this, you can actually control what corrections you're going to apply to each part so you can better match the profile, which is very important for the customers when you're exposing these tiny features. So technologically, they introduced something that was a big innovation and a paradigm shift in how things were done. Sorry?
Way ahead of its time.
It was indeed. It was, yeah, they were the first ones to do so. And at the same time, the business piece of it, so they introduced the twin scan. The twin part of it is they introduced two stages in the machine. So again, the way the machine works is usually you would have one stage. Stage is basically a platform. You would put your wafer on it, and then you could expose it. Now, what they did is they introduced two stages. So you would think, why would they do that? So what they did is by doing the two stages, they used one stage to always keep exposing these wafers. So essentially you are manufacturing. But at the same time, while you're doing this in parallel, what you would do is you would use the other side, they call it the metrology or measurement side. So what you would do is you would gather information by reading what this wafer is looking like before you would expose. So you know when this thing swaps and you expose it, you know exactly the corrections you need to make. So what it means, it gave you better control of how you were going to control your process. So in terms of a factory or a customer, not only did you get better control, but you got faster speeds because now you can do this in parallel rather than first you do the measurement. So you're not really exposing. So that's not really output for the factory. But now what they did is, okay, do this in parallel. That way you're not wasting time, but you can still continue to expose. So that was a paradigm shift also that they introduced. At the same time, again, continuing with their strategy of making sure that they keep the technological advantage, they also introduced the immersion system, which was, again, never heard of in the industry, because now what you're talking about is giving the customer the ability to even shrink the features further while putting a column of water on top of the wafer on a stage that is continuously moving. So you can imagine the challenge of trying to control something with water on it, right? But you're still maintaining the exposure capability, which is, I mean, if you go, read up some articles on twin scans or you look at some YouTube videos, you'll be absolutely amazed of how this can happen, and it's happening. And it gave them the advantage of, without changing the column or the lens column, just by changing the numerical aperture, which was one of the reasons they did introduce the water surface. They basically could shrink the features further by bending the light even more. So if you look at, how you put a pencil in a glass of water and how the pencil looks like it's bent, right? That's basically the whole concept. So with that whole diffraction, what you do is you introduce a column of water, and the light bends a certain way where you can actually use it to focus in a way to expose these features. And that's essentially what they were doing, but much higher speeds and, of course, much more complicated. But that was the concept that they introduced, which again gave them a much bigger technical advantage compared to the other competitors at that point in time. And in terms of business, what they continued to do, just like they did with Carl Zeiss, now they also acquired another company at that time. It was called SVG, or Silicon Valley Group. Silicon Valley Group also had, in the US, had quite a bit of patents and technologies and other innovations that were beneficial to merge with the scanner technology. So those experts, so the people, the experts, the patents, and of course the technology also now give them more to build on top of what they were already doing. So this is how they built on that. But 2000s was also interesting to ASML in terms of one of the acquisitions that they made, which is Brion. So Brion is the company that works in computational lithography. So what that means is, essentially, there's the hardware machine part of the exposures, but then there's also the design part of how you can use your design features on your mask or your wafer or your reticle, as they call, that is used to expose. So if you pre-calculate certain things just by knowing, how light is going to bend, how your chemicals are going to react and all, you do a computation by predetermining, okay, I know that this is how the machine is going to work. If I can compute the corrections of what needs to be done, I can have even further control on the pattern that I'm exposing. So again, much tighter control on your process. So they acquired Brion, which was, again, something introduced the term of holistic lithography. So previously it was lithography, but now it's holistic, in the sense you're not just reliant on your machines to do the exposure. You can actually use computational techniques in order to introduce design changes to make sure that you can have better pattern fidelity and better control. And in the introduction, you also mentioned that ASML doesn't just make scanners, right? Not just the lithography equipment, but they also make other machines. So in the late 2000s, to that point, they also introduced YieldStar, which is another measurement tool. So what the YieldStar is, if I would compare it to simply, it's like a microscope, for example. So when you're doing the exposures, right? So you print something, but you want to check, hey, how good did I do in printing this job, right? So the metrology tool, YieldStar, can now be connected to your scanner, and it will feed back. So now it created a feedback loop, right? It says, hey, you're doing great, but if there's a drift in your machine, you can quickly read it, and now you can feed it back, like, hey, by the way, you need to adjust this parameter so you don't lose control. So now you have this feedback loop ability that also introduced by ASML, gave it more control over things. So again, so far, coming back to and kind of circling back to wrap up the answer, so far between Canon and Nikon continuing to make the steps they did, However, ASML took high risks, but also made some big leaps that was not only able to let it catch up, but again, kind of get ahead of the market. Now, the biggest separator for ASML happened in the 2010s and the 2020s, which is the EUV technology. So the EUV, or the extreme UV lithography machines, ASML is currently, as of today, the only manufacturer of these EUV lithography machines in production. And these are the most high-end machines at the moment that are continuing to drive Moore's Law. And that is one of the reasons, ASML is in the crosshairs and so much in focus of the global semiconductor technology, of why people are talking so much about why this is one of the most critical suppliers at this moment, because we are the ones that have been able to essentially make this technology, which used to be in R&D for about 15, 20 years, but now this is a production machine, and people and companies like TSMC that are our customers, companies like Intel that are our customers, companies like Samsung, Micron. So these are some of the biggest names in the industry that are serving our global appetite for semiconductor chips, and they are all our EV customers as well, in addition to the other scanners. So in a nutshell, yeah, this is where ASML is at. At the same time, we continue with some of the acquisitions we recently made for HMI, or Hermes Microvision. And then recently in 2018, we also made another acquisition with Berliner Glass, which is another supplier for our key modules. So these two things, innovation and making strategic partnerships, is what ASML has been able to continually build and leverage to build this current position in the market.
It is really interesting that you touched upon the term strategic partnerships. So
Yes.
I read an interesting article about Peter Kerr's putting a golf ball on the moon. It
Yeah.
talks about the UV optics that Zeiss is developing. Though I do not have the photonic engineering background like you have, and so I won't be able to understand the technicalities of that article. But it appears that ASML has somewhat mastered the supply chain of precision equipment for carving the circuits on the piece of silicon, right? And I also remember back in 2010 or 2011, I guess, I had that Nokia Lumia, the Microsoft smartphone, right? So it
Mhm.
used the Zeiss lens, and that lens was really like the photos that I used to take were it was just next level, I can say that. It was way ahead of its time again, and that's what precision is all about. And ASML has always thrived on that, right? So coming back to the question, how does ASML manage to sustain this complicated supply chain and partnerships with such precision experts like you talked about, Zeiss or
Correct.
Timer? Can you touch
Yeah.
upon that?
Excellent question. So, there's a saying that they say that if you want to go, want to go by yourself, you can go very fast. But if you want to go far, you go together, right? That's what will take you far. And if I look at, I've been with the company for about 13 years, but I've been in the industry, even as a customer for these machines, for more than 15 plus years. So the biggest strength that continues to be for ASML. So before I answer your question, I want to talk about the DNA of what ASML is, right? So as of this year, our current CEO, Peter Wenick, he had the Q4 2023 earnings call. And this is a public presentation you can actually see on the ASML financial reports page. This is a video, and he talks about, if I would ask you, Nisarg, if you wanted to take a guess, can you take a guess how many different nationalities for the employees of ASML? How many different nationalities would you guess are currently working at ASML global offices? Just take a guess number.
Maybe 30 to 40 plus nationalities.
So that's what maybe somebody would guess, which is also, again, quite multicultural, very diverse, right? Bringing a lot of new thoughts and ideas. Currently, there are 144 different nationalities of people that work at ASML. The reason I want to mention this is ASML, in terms of building its strategic partnerships, has never just limited itself to be like, okay, if we are in Europe, we limit ourselves to Europe. And this is why in the beginning part, I wanted to share the history of how ASML came to where it is, because it found its key partnerships like Cymer, as you mentioned, in San Diego, right? So that is one of our key partners, and also part of that is also part of ASML now. Same thing with Zeiss. So Carl Zeiss has been one of the oldest initial partners, and in the EUV world, Zeiss has been one of the key reasons. I mean, the two partners always have to walk, lockstep with each other, especially when you're so in front of everybody else that you really need to be able to understand, because none of them have seen what's ahead of them before. So you have to be able to be on the same page. Same thing in terms of the EUV world. I'll talk about another key supplier we have, which is Trump, another German company. And Trump also is a laser supplier for us, and they are also primarily one of the reasons that EUV technology is where it's at. But coming back to your question, I mean, right, and it's a very good article that you referenced there, because a lot of the changes that have to happen have to be well communicated to your key partners, because ASML, if you look at it, is a systems integrator, but it has identified and being able to keep its key suppliers on the same page, so that when you can see the same vision, you talk the same language, and when you can explain to each other what you want out of each other, that's exactly when you are able to make the steps that you need to, right? So that is one of the reasons why ASML has been able to be there, is because of these critical strategic partnerships, and being able to keep those partnerships, like I said, to go long term and not just have short term gains or short term results, but to be able to keep each other on the same page so they can continue on this path.
Interesting. So, I mean, you talked about the internal partnership that ASML has with these precision experts all around the world, and you have always been thriving on the strategic partnerships. So,
Yes.
it is interesting that ASML started in the peripheries of the semiconductor market of 1980s, and today, after the pure play foundry model, it has completely reinvented the industry, as most of it comes from working very closely with these foundries, which are the
Mhm.
external partnerships of ASML, right? You can correct me if I'm wrong here, but if we talk about these external partnerships with these foundries and chip designers as well, so how has this synergy of ASML has worked out with your customers who use your cutting edge technology, your cutting edge engineering products and services?
That's an excellent question, because indeed you're right. To build our ecosystem, we we are customers of our suppliers, right? But what you referred to is exactly, we have customers and now we are their suppliers, right? So thinking wise, again, what we do internally also needs to translate externally
Of
to
course.
form these kind of relationships, because now we have a recipe for success that we see, but of course we need to now switch the roles and be suppliers in order to serve our customers better, right? So I will touch upon a couple of things. So you mentioned some of the foundry customers, so I'll talk about TSMC, which is the biggest foundry customer worldwide and one of our critical customers. Some of the other key customers we have, like Intel and Micron also, which are not foundry customers yet, but Intel, if you read in the news, also in Arizona, is building a foundry fab as well, in addition to just serving their internal CPU needs and other products. Same thing for Micron. They've been using our products to build memory products. So they're not foundry, they're not building for others, but they're building basically with their own fabs and supplying to other markets as well. Key thing to answer your question, the key thing that we need to do is, again, our product is only as good as what use the customer can make out of it. So we have to be very receptive, because if you run too fast, or if you run too much far off compared to, like, it may be the best technology, but if it's not addressing the needs for our customers, then the usability and the market is not there. So what we continue to do is we have very strong teams that focus on, so we have technical teams within ASML that focus with our customers. We listen to our customer. The voice of the customer is very, very important for ASML at all levels. It starts from us spreading out globally where our customers are, but we need to make sure that this voice lands in our central team where most of the R&D work is being done, and these products are being integrated and coming together. So what we have is we have roadmap alignments with our customer, the technical roadmap alignments. So you will see that there are many technical conferences, SPIE, and other global conferences that where our customers present, and they will show the roadmap of the cadence of, hey, we're planning to introduce this node by this year, and this is our performance requirement on this particular node in order to meet the output and the technical needs of what our design needs to be. ASML, of course, is part of attending these conferences and at the same time presenting what our product roadmap and offerings are, right? And some point in time, you need to match these two. You need to marry these in terms of making sure that the requirements and the supply really synergize with each other so that they can be a seamless transaction. So every single time we have new product introductions, we engage closely with our customers to understand their needs. They do evaluations of our products, and of course, they give us feedback, which also makes us understand where things may be, a little off, and where we need to tighten things up, or we maybe need to loosen things up. So based on those requirements, we continue to look at our foundry customers and our pure play foundry customers, and also just memory manufacturers and also logic customers worldwide, to make sure that their voice is heard and our products are continuing to match what their requirements are, such that we can continue to serve their current needs. We can understand how long those markets are going to be, but at the same time, we are continuing to look at the future, of what their needs are. So I don't know, most recently, one of the most hottest news out of ASML has been the high NA EUV, which is another paradigm shift. At the end of 2023, this is the world's first and only production high NA that was shipped out to one of the customers in the US. And now there are going to be more, as other customers are now also starting to engage. So again, what happens is these machines, the first proto, after the first proto in the factory, the first production machines are sent out and customers evaluate them. And then there's some, fine tuning. We take the feedback and then we fine tune the designs and we tighten things up in order to make sure they have the performance requirements they need out of it. And that's how we keep closely lockstep with our customers to make sure their needs are served.
Yes, of course. As I said in the introduction, that ASML is a certain level of vantage point in the semiconductor ecosystem that you also talked about in this answer. So, as a representative of such a company that sits at the center of the integrated circuit manufacturing, what does a chip manufacturer like? Manufacturer, as in the fabricators as well as the assembly plant, such as the TSMC or Micron, as a matter of fact, what do they look in for a national ecosystem before they intend to set up their cutting edge fabrication or assembly facility in that country?
Yeah, that's a good question, because right now, if you look at it, you hear a lot about, and India is at the center of this as well now. So first of all, it's a business, right? So as a business, what companies are looking for is there a market that they need to serve, right? is that a good business decision, which may be guided by a lot of different things? It could be the geopolitics of things, the reliability of being interdependent or independent rather than interdependent in some cases, and self-sufficiency, right? In terms of forming some strategic alliances also, right? Between making sure that the supply chains are there and the technology is there, because you must also be hearing a lot about the current restrictions that are being put on some trade with China and the US as the situation has been evolving. So all of these put together are part of what is also creating a need for governments where they're realizing, hey, we need to have some sort of self-sufficiency. And that's why we want to build our capacity. So Europe is talking about, or has already talked about, a CHIPS Act. US has a CHIPS Act. China is now also in the middle of trying to expand and very aggressively expanding their own semiconductor manufacturing capabilities beyond what they already have. Taiwan and Korea, that have been at the epicenter in the last 15 plus years for this, are also looking at offshoring a bit, because one of the things that you think about is these industries are very intensive in terms of utilizing a lot of energy because the factories that they set up need a lot of energy support. But at the same time, they need some facilities like water, gas supplies, and things like that. So the natural resources that are needed for that. So as these companies are looking for opportunities to set up outside, they're looking for the CHIPS funding or support in order to get them situated and set up in the new locations. But at the same time, they're looking for ecosystems such that you cannot just build a factory but not have the facilities to support it, right? So you need your suppliers also present in the area. You need a good supply chain to be able to have a continual input so you can continue to have that output. At the same time, you need good workforce, right? So this is another one that I would also want to mention, that for the US as well right now, there's in terms of, say, if I look at myself, yeah. So I have my background in electronics and communication engineering, where I did study digital electronics at NIT. Then I translated that into my master's in microelectronics, where I studied nanotechnology. But at the same time, our university at University of Arkansas has a small, almost like a small fabrication unit that has all of these steps, again, at a much smaller scale, like a lab scale manufacturing unit where you learn these things. And then, the packaging and the packaging of these chips so that they can be transferred over to the different applications that we use. So this kind of ecosystem is also needed, but at the same time, you need a workforce that really understands the language, the jargon, and is able to support these factories as well. So these are some of the key ingredients that the companies are looking for, like their key suppliers, right? Being there, the government policies, because again, if the government policies make it too difficult for some companies to do business, then the entry barrier becomes too high, and then now it's difficult for the companies to just focus on what their core competency is, which is technology and manufacturing, and they're too busy trying to fight the other things, which can also create a lot of rift and a lot of friction, and it's not always the most productive thing. So that environment needs to be in place in order to nurture, especially in newer markets right now. And I'm not going to say the US is a newer market, but in terms of bringing advanced manufacturing back, right? This is something new, because at one point in time, these factories used to be in the US, they moved to Asia, and now it's kind of going the other way, right? It's re-entering into the US. So again, that needs to happen, and the policies need to support it, and the infrastructure needs to be in place such that that the business part of it becomes more seamless.
That's an interesting proposition that you said. You need that ecosystem in a nation to enter into that market. So on that tangent, I see that ASML is present in 16 countries. Correct me if I'm wrong. Is it 16, or maybe it might be more than that? So ASML has its R&D centers and customer operations in 16 countries. What led ASML to choose these locations? And as you said, that conducive industrial policies by the government is a dominant factor. But the human talent, the quality of talent that you are getting, who will work in those R&D operations, is that also a factor? And how should a national ecosystem develop that to attract such technology in their own country?
Yeah, no, very good point. So, so there's two key components for companies like ASML to be able to, well, first set their advantage, the technological advantage, but then be able to increase the gap. So I'll go for that step by step. The first one, in terms of setting up the technological advantage, is you need to be innovative. You need to find things that are leading in terms of the technical roadmap, right? Things that have not been done before. And this is where the R&D centers come into play. So, for example, IMEC is in Belgium, is one of the key educational institutions that ASML has really strong ties with. Same thing in Albany. Also, the Albany Nanotech Center is something that uses some of the ASML equipment in terms of many companies coming together, doing, forming some partnerships and doing more of a pathfinding for what's next, right, by using these machines. And then in the process, also providing feedback towards ASML as a supplier of what they want to change or improve out of these machines. So first, focusing on the R&D piece of it. So innovation is something that is not limited to one region. I mean, there could be some good things that you can learn from many parts of the world, right? And this is why in the beginning I mentioned that ASML right now has about 144 nationalities, people from 144 nationalities that work from them, because that's also something, when you have different ideas, when you don't just do things just one way, right? And you find innovative ways of doing things. And this is by spreading yourself and connecting yourself with these high-end R&D centers and reputed organizations, you give yourself a better chance of continuing to make sure that you're not looking at it from just one perspective. You have like a 360 view of how many different things could be done. And these also in the industry, as you always are looking for, is these key institutions, educational institutions and R&D centers have ideas that now coming to like setting up the bar, right? So you set up an innovation, but now you want to make it like a high volume. You want to make it production, right? So to be able to take that idea and to make it like something that, okay, needs to go into high volume production, that's where you would bring it to like an industry view to it. You get business people on it, you get marketing, you get the market analysis of what's needed. And that's when you bring the business view to it of how many units we need, what our customers need. So the sales teams come into play, the financials come into play, right? So all of this now goes from an idea to a product to now something that you can actually make in high volume, right? So this is how pretty much it happens, and this is where the R&D centers become very critical to get the technology set up. But then, how do we also keep in mind that these are not just technologies that can be done once, but not at a high volume scale. The second part of establishing ourselves globally is because ASML has customers worldwide. Like we have customers in Asia, we have customers in US, we have customers in Europe, all over the globe, right? And we have a list of all of our our locations on our company website. So ASML is also the key thing in what was mentioned earlier, and you touched upon the word customer support, because the organization that I am currently working with here, and we call it like in the field. So we have our headquarter, Netherlands, and we call this the field. So field is where our customers are setting up the factory. And when our customers are setting up the factory, it's our responsibility to make sure that we don't just deliver the machine to them, but we make sure these machines are installed correctly, right? These are very, very complicated machines. So there's a lot of responsibility upon us as a ASML to make sure that our customers get a product that they expect out of us, but at the same time, we are able to service it and we are able to maintain the performance of these machines if something was to go wrong, because then it is in the critical path of their production, right? So we need to, and most of these customers that have factories, the factories run 7 by 24, like any other production factory. So we have service organizations, which are customer service organizations, which are located very close to our customer factories, so that we are able to service these machines, we're able to support these machines, and at the same time, more importantly, we're able to listen to the voice of the customer. So I come back to what I started with, right? The voice of our customer is very important, because at the same time, when we provide them with these machines, the market conditions keep changing, their product mix keeps changing. So when this machine is used for a few nodes, because when they invest in the capital equipment, they want to get the return out of it. So sometimes they will also push it in terms of the design specs of the machines, but what their requirements are. And that's where there are also a lot of good exchanges that happen between us and our customer, where we are able to understand from them how is their business changing, how is their market requirement changing. And as teams, customer teams in the field, we take that feedback and we send it back also to our factories, like, hey, this is where our customer needs help. This is where they're headed. This is what they are also hearing from their end customer, right? Be it good or bad, like, hey, this is something they like about their product, which is part of what our systems are capable of, or this is something they would like to see in their product, which is also an improvement opportunity or the next step. So being present closer to our customers in that sense not only helps us deliver good service to them, but also helps us make sure that we can fulfill the commitment towards them, but bring their voice back to ASML. Again, coming back to the synergy, you always want to be lockstep and close with your key suppliers and customers, make sure that you are on the same page and you understand each other. So when things shift a bit, you can sense it quickly. Unless you're too far and this thing's moving, you have no idea. But when you're lockstep, you can quickly sense it, like, okay, something needs to change, we need to fix it.
So communication and consensus is the key for the synergy to work, right? And
Absolutely. And again, that two key words indeed, communication always. But consensus, even if there's not a consensus, but at the same time, to be able to communicate when you're not even in consensus, because you don't always have to be in agreement, but at the same time, you have to be able to see from each other's perspectives and then be able to build on it. So that's key. But yeah, communication is always key.
so as you said, capital investment in this industry is very high, and your customers are the one who will be taking the risk first in a national ecosystem, and you will follow them for their requirements, right? And these investments, such as the one happening in India right now, they are greenfield investments, right? And it needs a patient capital, like that capital to generate returns. It needs a long haul to get things done the way they want, right? So Micron has established an assembly and packaging plant in India. In fact, it is very nearby my house in Sanand,
Yes.
Gujarat. And the government of India has launched India Semiconductor Mission, where it has announced the capital outlay of 76,000 crore rupees, which is somewhat equivalent to $9 billion, right? For developing the semiconductor ecosystem in India. And even the provincial governments, the state governments, such as Gujarat, Odisha, Karnataka, even Tamil Nadu and Uttar Pradesh also announced their own semiconductor policy. So,
Yeah.
with such heavy governmental support in developing this chip making ecosystem in India, what do you think a new entrant who aspires to enter into this industry should focus on right now to attract such investments?
So the key is, again, at the end of the day, these companies have the choice to to be in a different market as well, right? So right now, like I said, so Europe, US, China, Asia, everybody has this CHIPS Act funding. The key, especially from a new entrant perspective, is we have to be able to, as a business, if somebody is looking at it as an opportunity, these are, like you said, longer term returns on investment, because first it will be a long learning cycle before you can start seeing return. So that longer term vision and policy has to be in mind when you're shaping up and inviting companies such as industry leaders like Micron, in order to make sure that you can set up a success story and a good example. So again, yeah, these are some of the initial steps, but there's more to it where just the funding is not going to be enough. So currently, if you look at the semiconductor industry in general, and I will talk about, a normal day in my life is I support a customer that has built a factory here from Taiwan, right? So I start my day making phone calls in the morning with my time zone in the US, where I have people in my team that are from Korea, from Taiwan, from Germany, from Netherlands, like in my team locally over here from all of these different countries, Vietnam, all working together to support this local ASML office. Belgium, I mean, I can go on and on. The more I think, but this is in one office. So this is a typical day that happens. And then I make phone calls to Netherlands in the morning to align with my headquarters. Then I come back and then I'm talking to my customer who's here from Taiwan. So culturally, we're mixing with different cultures. At the end of the day, in my evening time frame when I'm closing, Taiwan is waking up, right? So I make phone calls to my ASML counterparts in Taiwan. So what I'm trying to say here is this is an industry that goes 7/24 right now, because of how the suppliers are set up, because of how the customers are set up, and because of where that factory ends up being, right? So there's a lot of intermingling of cultures that need to happen. To be able to support such a environment, the first thing is you have to be open to diversity. Diversity, I just don't mean by diversity of just how people look or what language they speak or what food they eat. Diversity of thoughts in terms of being very open-minded, like this has not been done before. Let me not be the one who says that I can tell you how it's done because this is where you're operating. Currently, there's a lot of ideas, so we need to learn from the industry experts of how they've done things. And the more we can learn upfront, the better those things can be supported in terms of how the local infrastructure is built up, how those policies are being built up, right? And how they can integrate well, because these businesses need to work globally. So the policies should be such that, they should be easily transferable in terms of place A to place B. So that kind of seamlessness will, again, with the already higher entry barrier of trying to learn the technology, if we can lower the challenges in terms of being able to cut all of that red taping, so to say, right? And that will really help the industries to find that conducive environment to bring in more people who are like, okay, I like the work environment, I want to work here, I feel like I belong, even if I'm not in the same environment that I'm used to. But that whole the diversity is what really in this industry, and I continue to see day and day. And I just actually came back from a dinner I had as I was driving with my Taiwanese colleagues and my Chinese colleagues, because we were eating hot pot with them, which is, again, this is the beauty of what it creates. And once that environment is created in that area, then you will see the influx of talent, of resources, and people who really want to support such an operation. So I think that would be something that's key, which is not so tangible in terms of how do you measure diversity, right? It's just something that over time develops, and it's a feeling that people walk away with, like, yeah, I like to be here. So.
So you talked about the diversity aspect of it, and that on which the industry thrives. So I recently attended a semiconductor panel in a business summit in Gujarat, the Vibrant Gujarat Global Business Summit. So I came across a panel discussion where there was a lot of discourse in developing that semiconductor ecosystem in India, and diversification was one of the important aspect of it. Uh, though if we think about the Indian ecosystem, and I'll be very specific about the Indian ecosystem, it is at a very somewhat a nascent stage. There are
Mhm.
lots of things to learn right now for the Indian ecosystem. About that, the human talent should be diversified, and the policy should be a means to develop that market rather than being a barrier to it. So
Absolutely.
so is ASML monitoring this, what is happening in India, and does it see a potential in the Indian semiconductor manufacturing as well as the designing ecosystem?
Yeah, so again, like I said, ASML has continued to serve our customers in many global footprints. So initially, like ASML started out in Europe, right? As I said, so it had the presence in Europe. It started in Europe, then it moves to the US, where it set up, more of a footprint. As the manufacturing moved to Asia, and then ASML equipment is used by our customers in Asia. So some of the key customers in the industry, TSMC, Samsung, Intel, Micron, Hynix, and others, these are but some of the key ones I mentioned. They are all users of ASML equipment. So if our customers find that they need to uh, set up their business in India, or for that matter, any part of the world. Uh, One of the key things for high volume manufacturing customers is something for process transfer, right? So if you do something in a factory, if you want to do it in the other part of the world, you don't want to introduce any variables, because that's when you introduce things that you don't know might have an impact on your product quality. The fact that most of these customers already are users of ASML products, as they transfer or build up fabs in India for the products or technologies or nodes that they want to either introduce or ramp up, inherently it will create a need for using more of the equipment with suppliers like ASML, amongst others. So for us, at that point in time, when our customers get interested, it automatically puts us in a position where we have to, like I said, as a customer support site, we have to also start studying that, okay, if our customer is building a factory here, we need a customer support center there, which means we need to start preparing for things like, hey, what does the policies look like, right? We have to set up offices, we have to hire people. What do the hiring policies look like? What are the pay scales for the people? Can we transfer people who have really high pay scales, say from the US? Are they going to be interested? Are the salaries competitive? What is the work environment like? What's the infrastructure like, right? Because not only do you want to support the customers, but at the same time, as a company now looking inward, you want to make sure you build a team that is going to be successful, that is going to be settled, right, and be there for the long term. And at the same time, you're also looking for hiring from the local talent, because that's part of the job creation that it also does. Because when people are being hired from the local area, local talent, then there's a better chance for them to stay, and then they build up their competency. So those are the training opportunities for how do we hire from local universities, right? How do we source from local suppliers? So those are the opportunities that it creates. So as a supplier, when our customers start to look at these opportunities, and when they share with us these kind of plans, for us, automatically, it also triggers these discussions, and then we have to get teams involved in terms of making sure that we are able to support them.
Okay. So there are some expectations from your side from the Indian semiconductor ecosystem, and that is your customers should have a good thing going in the industry, and you will follow the suit. you will follow them because they are your customers and you have to cater to their needs, right? So there's also a lot of talks in the advanced packaging aspect. Like
Yeah.
people say that after the pure play foundry, this is the next big thing in the industry. So is there a truth value to it? What's your opinion about this?
Yeah, so advanced packaging, definitely, it's not competing, or it's actually supplementing the chips. So packaging essentially right now is indeed, and especially like you said, advanced packaging, like the term CoWoS, which is chip on wafer on substrate, COW, as introduced by TSMC, or Foveros by Intel. So a lot of what is happening right now is these key players, what they're focusing on is not just building these chips that do a certain functionality, but integrating them into packages such that a memory chip is working with a logic chip in order to fulfill a certain requirement. For example, the EVs, electronic vehicles now, like Teslas and all of these vehicles, right? These are creating new requirements where you have the imaging requirements as these cars are walking, they're taking thousands of pictures, but you're processing them, right? So you need your memory to sit on a chip and collect all of these images to be able to feed into your processor so you can process it. So these kind of applications are creating the need for advanced packaging such that the performing chips can be matched with a high performing memory or storage, and then together they can deliver a functionality that is application based. So advanced packaging is, again, just to reiterate, it's not necessarily kind of like a post pure play foundry, a big thing. It's a complementary need. It is required. All of these chips that are built by, say, TSMC or Intel or Samsung, they or Micron, they need to be packaged into packaging such that they can be delivered onto a certain application, like a phone or a car or television screens or smartwatches or things like that. And that's where the advanced packaging is coming in. Now, what is also happening is advanced packaging, the requirements for advanced packaging continue to become more and more stringent. So it's a very interesting topic in the industry right now, because what is happening is, because you can imagine, if you take a chip that is used for processing, if you use your laptop sometimes, if you may hear that the fan goes off, right? Because the processing chip is heating up, so it needs to cool down. Where there's other applications, for example, if you're just using your USB, it doesn't heat up because it's like storing, but it's not processing per se. So memory chips versus processing logic chips have different kind of behaviors, where one is processing, is generating a lot of heat, and now this other one is, say for example, is not generating so much heat. So now you put these things together close to each other, and now if you need to create an environment so that you can maintain the thermal stability of this environment, your need becomes something completely different than what it would be if you would treat each of them in isolation. And that's where advanced packaging challenges are coming, because now these things are mating with each other, and that is creating how do you package them, how do you stack them, how do you maintain the reliability for these chips. So that's where advanced packaging is becoming a more important topic also in the industry, because these high-end chips, again, need to be packaged and need to be delivered. So there are companies that are working, including not just Micron and Intel and TSMC, but there are also some just pure advanced packaging companies that are focusing to support these foundries right now to make sure that these chips can meet the final applications.
I didn't know this much about the advanced packaging. I guess there was a popular sentiment that advanced packaging will be the next big thing in the industry, but it turns out there is a lot of things that needs to be done vis-a-vis the integration of the memory and the processing aspect of it. So, I mean, we had a really long conversation, and I mean, we are at the threshold of the end of this interview. So, my last question to you, sir, is you have been in this industry for a long time. I mean, more than a decade, as you said, 13 years. And a lot of things have changed that you have witnessed it. Like you have seen the world change from a node to node, if we can use the industry jargon. So, what is your perspective, not just from the industry, but for also for someone who intends to enter in this market as a career, as a foolproof career in microelectronics? So,
Okay.
what career advice will you give to the people who intend to make it big in this industry? Like, what was your experience and what should they focus on right now to develop that?
Yeah, so I kind of reflect upon how I got into this myself, right? So being a student of this industry for such a long time, and still every single day I continue to learn, because what I know now, 5 years ago, I thought that would take forever, but here we are, right? And we continue to push the boundaries, like you say, and set up the bar even higher. The key thing for somebody who wants to get into this as a student of this industry, and by student I don't necessarily just mean to limit yourself to the theoretical part of the electronics or the physics. It's important to understand that there's a lot of innovation that is being done, but at the key of it is it should be driven to improve the quality of life of people, right? So, for example, there's smart cars being built, there's smart watches being built, there's smartphones being built. So, how do you leverage this industry, right? And by being a student, what you understand is not just the technology, but the application piece of how the technology can be applied. So from that perspective, I think the biggest learning I would want somebody to take away from this is to understand the power of what the machine can do for us, but to be able to translate into what the impact of that on humankind would be. I think that's what really makes it powerful. I mean, everybody has a smartphone, but what you do with it is what really makes, how much you can, what the value is, right? If I just take photos of food and do anything with my smartphone versus somebody can run a whole business from a smartphone. So just be open to the idea of, just be open-minded in terms of continuing to learn and understand how do you apply technology in order to have a bottom line impact to something. I think that's key. Secondly, in terms of not as just a student per se, but for a country like India right now that is stepping into and making the right steps right now, from what I see, I would hope that this continues, and not just the governance helps the private sector and the industrialists and the entrepreneurs and the thinkers and the innovators. And by that I also mean the universities, because these ideas, a lot of these come from the universities. And when those programs can be supported, that really sets up a whole environment of like people helping people, right? And that's what really starts to butt into like a success story for ASML that started from a small shed to this year is going to be the fourth decade, 40 years since 1984. So 2024 is going to be 40 years for ASML. And looking at that as a success story, it's not just been the technology, right? It's continued to be they've all ASML's always found a reason to be able to say we can do this when everybody said this cannot be done. And that's the mindset that you have to have, that just the fact that it hasn't been done doesn't mean that it cannot be done. And that's something, if you start with that, then every person, if they can approach it, whatever angle it be, right? Be it universities, be it business, be it a consumer, be it government governance policies and all, it needs to be like, this is important for us. So failure is not an option. The question is, it cannot be done this way. What is the other way you can do it? And that's key.
Ah, thank you very much, sir, for this insightful interview. I know you are a very busy man. We have been collaborating a lot over WhatsApp and email. And you taking us your precious time for us. We really appreciate you for that. And I hope we can host you again on another Geo interview with a new topic related to the semiconductor industry itself, but from a
Sure.
different perspective. And I personally really enjoyed this conversation. I mean, I always like to talk to people who have somewhat a sense of how technology works. I mean, in ancient Greek, they like within the narrative of a play, they used to use the technology to summon gods in the play. Like
Mm.
whenever you want to introduce the character of God, they will use the levers and pulleys. So, like
Nice.
Greek used to see God in the technology itself. So, like the technology is the God for them, and that's a really interesting cultural aspect of the Greek philosophy. And again, thank you very much, sir, for doing this, and I hope to host you again.
Absolutely. And again, thanks for setting it up. It's been yeah, really good talking to you. Again, it's exciting also for me to be able to see that again, I'm still, of course, I was born in India. I'm connected with India. I try to stay up to date with India, watching a lot of YouTube videos, particularly about semiconductor industry, trying to know how, because I have been a student of this industry and I continue to be. So I've seen some changes. So, but it's always good to be able to reflect back on how India is going to take, how this is going to take off in India and how this is going to shape up. Again, it remains to be seen, but from what I'm seeing from a distance, at least I hear the right things so far. I see the right things, but I'm really excited to see how this shapes up for sure. And hopefully, someday, if I do get the opportunity to be associated with one of the projects that take off in India, I would definitely give it a very strong consideration for sure. See if I can be part of that.
I look forward to that, and I assure you that day will come.
Yeah, look forward to it as well.
Yes, sir.